Good morning. In this manuscript, we have described the new mechanism on how SARS-CoV-2 is propagating inside the cells, especially using a system inside the cells to regulate the ATP2B1, also named PMCA1, that is a calcium pump dependent, that flux out calcium from the cells to the outside cells. Now, in this paper, what we have demonstrated that once SARS-CoV enter inside the cells, there are three important mechanisms that will influence the P1-3 kinases signaling. And in particular, FOXO3 family are quite important transcription factors that are regulating then the transcription of both the pump PMCA1, also named ATP2B1, and the transcription of ATP2A1. In a regular condition, these two transcriptions are turned off, and what's happening is that the calcium is through the SARS-CoV infection, it's impaired to the exit by functionality of SARS-CoV and down-regulating the expression of ATP2B1. At the same time, what we observe is that the virus is opening up an important pump in the sarcolemma, that it pumps in the cytoplasm the calcium. And this is very important because the virus is need the calcium for replication and then exit from these cells. Indeed, we found a drug in collaboration with our studies in the Korean group where the P17 is able to block this entrance by impairing the functionality of ATP2B1, impairing the potential of being lowering down by the viruses at the same time. And at the same time, it works with the regulation of ATP2A1. And the drug in vivo, like we saw, impaired this phenomenon also called syncytia formation. So in this way, the drug is able to avoid the enhancement of replication inside the cells. But what was even more interesting, that we found in a population of people that was sequenced that an intron inside this gene and in the genome, there is a very low frequencies of 0.3% of people that has a mutation in the genome that in the regulatory element of ATP2B1. And what we prove in this manuscript that this mutation affect the severe COVID infection. So once the mutation is occurring as a polymorphism inside the gene, these people then will have a severe COVID. And in our manuscript, what we prove is that to remimic this function in different cells by using a Casper-Chris analysis and proving that these cells, once are mutated in these catalytic sites of infection for ATP2B1, is then able to get much more infection than the other clones. So this is another important step forward with forward genetics, where we know that if the genes is present with this polymorphism, then it will infer a severe COVID infection.